in the test. In the test, I give you the equation for the circle, for example. For example 1. Let's do it completed. Let's give you the equation. But this equation is not expressed in standard. No, it's expressed, but it's expressed in general form. Remember, standard is, guys, stop the messages, okay? Okay, you after the class, you interchange telephone number, WhatsApp group. Okay, pero no now, please. Pay attention, focus, coño. Okay, now, now you hear me now? Good. I don't know why. I can hear Professor. Edgar, do you hear me now? Okay, good. Yeah, no more messages, please. Okay, now this is the general. General is that format. You put a degree 2 first, ax plus by plus d equals 0, right-hand side 0. This is typical. This equation given in this example is obvious. It's expressed in general. Entonces, what is the question? The question is, number one, change this general form to standard, number one. And number two, do the graph of the circle. Okay, let's do it. Let's do it now. Okay, this is the explanation. What is a standard? What is a general form? Now let's do our problem now. Okay. So now, if you want change from general to standard, you make a completed squared procedure. So you copy, for example, x squared, you grouping the guys que contain x squared plus 4x. Plus, I have no idea, you put a box. Remember, inside the box, you have a number que complete the square. A similar idea we are doing repetition for the y part. Another completed square number. In this case, you have 2 because it's x and y. In the right-hand side, we have minus 12 plus 2 boxes. Okay, this is the organization for the completed square. And remember the magic number, the formula for the magic number is b over 2 squared. Exactly the same, the thing we are doing in the solution of the quadratic equation by completed square. Here is this same idea. In the first example, f4, b4, 4 divided by 2 is 2, and 2 squared f4. It's a coincidence, it's 4. You put 4 here and you put 4 here because you introduce artificially that 4 to complete the square. In order to keep the equilibrium of the equation, so you introduce artificially 1 4 in the left-hand side, you put another 4 in the right-hand side. The second number can complete the square is 6. I don't care the sign is not important. 6 divided by 2 is square. 6 divided by 2 is 3, 3 squared, 9. 9 here and 9 here. Okay, now, I know very well. I know very well. Okay, this first trinomial, is perfect square, and this second trinomial is perfect square. And the factorization is only one parenthesis, x plus 2 square. Welcome from that 2, square root 4. Welcome from this x, square root x square. Plus, if the y is similar is y, but in this case minus. Look, the sign is important, is the first, and the square root 9 is 3 square. In the right hand side, we have this and this together, a 13 and 13 minus 12. Boom. And this is clear. I transform using the completed square procedure the equation from the general to a standard. Now it's a standard, the standard everything is clear, and you can see the center. Be careful now. The center of this circle is located at the point -2,3. Remember, very important. The sign of the point is different to the sign of the equation.
Professor. Okay, so on this equation right here, x plus 2 squared plus y minus 3 squared, isn't the number supposed to be 13 over here? Because he wrote 1.
Yeah, because the 13, Jasmine, is 12 plus 13 is 1, positive 1.
Oh.
Okay, I combine. Good? Good or not good? Jasmine?
Yes, it's good.
Okay. Now the radio is 1. It's a coincidence because, you know, actually is no is square root 1, but square root 1 by coincidence is 1. And so this is the two pieces of information that we need to do the sketch of the circle, because it's my final goal. My final goal is do the sketch, so I graphic the circle whose equation is the original equation that's given. No? Okay, let's do it. Let's do in the most not complicated but interesting part. Okay, we are doing the rectangular coordinate system. Okay, rectangular coordinate system. All right, let me try to do here. Okay, that part is not important. Now ready. The center. The center is located at the point -2,3. I plot that. -2,3 is here. Boom. A ver, let me show you. -2, 1, 2, 3. Here. It's the center. This point. I plot that. And from this center, I know that this radio is 1. So this is a little bit a small circle. Radio 1 in what direction? Up, down, right, left. So you have 1 point here, 1 point here, 1 point here, 1 point here, because the radio is 1. This distance is 1. Okay, by the way, see if this point is the point -2,3, get the center. That point is -2 again, pero 4, no? Because the y component, get the second number, is increasing +1 because you move over. And this guy is -2 again, the same component x, but y decreasing 2. Now, okay, Victor's image. what is image? What happened with the image? Victor. And this point is the point -1, negative 1,3. So in this case, when you move, for example, to the right, the x component increasing +1. Si es -2 +1 es -1, and the y component stays the same, -1,3. And likewise, happening in this point, que es -1 again. No, -1, -3, sorry, 3. Okay, so what is my final answer? My final answer is a circle like that. Boom, boom. I try to do my best. Okay. At the beginning, the equation is given is equation in general form. This is a typical question in the test number 2. Okay. It's given. The yellow box is given. You need to manipulate this equation and convert to a standard. Standard is this one. How we are doing this? Using completed square. Immediately when you see this equation, you can find center and radius. Okay, remember the formula in general is x minus h squared plus y minus k squared equal r squared. In our specific example, h is -2, k is +3, and radius is 1, r squared is 1. Therefore, square root both sides. R is 1 because it's square root 1 is 1. Any question? Okay, I have another. And also we know, I want to show you the same example, this example I did in decimals. So I appreciate so much if you are be familiar with decimals in college algebra. Because any graph, not necessarily do it by hand like that. No, we can use in decimals. Let me try. There you go. This is decimals. Okay, let me share the screen for see decimals. Switching. Okay, decimals. Do you see decimals? Okay, super. So look, I mean, this is example number, let me see. A number, this number. And number 5, yeah, number 5. Look, boom, number 5. Okay, and number 5, look at that. And number 5, I put the original record. However, I put also the standard when I manipulate, but in black color, and you see they are perfect coincidence. And this is clear because they are equivalent equation, no? The only thing I did was the conversion, so I changed the form, but it's equivalent. The same represent the same mathematical object is the circle. And the point, you know, when you plot the center and the 4 fundamental point is moving radial to the upward, downward, left, to the left, and to the right. To the right and to the left. Any question? What part is confusing? It's clear? Come on, opinion. Okay. Let's do one more example.
It's clear.
Good. Let's do one more example. Let me erase. Okay. Example. I emphasize this because it's important. It's important because you see one question in the test exactly like that. So it's x squared plus y squared plus 4x. That's the second example we are doing. 6y plus 9. equal 0. Okay, I give you the new equation expressed in general of the circle. Step number one.
Uh,
I don't hear. What do you say?
I I say I say I cannot see the whiteboard. I only see the Desmos.
Oh, oh, thank you. Okay, sometimes I forgot to switch in this. Now, miss, it's okay now?
Yes.
Super.
Yes, sir.
Okay, now,
Thank you.
look. Okay, no problem. I try to grouping that using the alphabetic order, no? X first, you copy the element that contain X only, the term that contain element. This is the box, it's the magic number to complete the square, and Y square plus 6Y plus another box. And the right hand side, we have -9, is this number. They move to the right hand side plus 2 boxes. This is the organization of the completed square procedure. Okay, now who helped me? What is the magic number in the first box? In this box? Question mark. Tell me.
4.
4. A 4, no?
Yeah, because 4 over 2 squared, it'll get you 2, and 2 squared equals 4.
Super. And what about the second? Another participation, not only Yasmin.
6 over 2 will get you 3, and 3 squared will get you 9.
Exacto. Okay, entonces 4 and 9. Entonces I forgot to write in the right hand side again 4 and 9. Okay, now ready. This trinomial is perfect square. And the factorization x plus 2 squared. This trinomial is also perfect square. And the factorization is y plus 3 squared. In the right hand side, when 9 is cancelled out with 9, stay only 4. And we compare this to our famous standard equation of the circle. I can see clear like water. H is -2. K is -3, opposite sign. Look, opposite sign, opposite sign. And R squared 4, therefore R alone is square root both sides 2. So the thing we are doing now is to the sketch of the one circle whose center is located at the point -2, -3, and the radius 2. This is the two important information to do the graph of the circle. Let's do it. This is the rectangular coordinate system. Okay. I plot the center first. Center is located at the point -2, -3, -2, -3. I suppose que es -1, -2, -3. Over there is a center. Okay, good. And the radius 2 in any direction, upward, downward, right, left. So we get this point, this point, this point, and this point. Okay. And we connecting this point using my skill in drawing. Okay, by the way, it's no good using that pen, is electronic pen. However, one fantastic way to do this is using Desmos, no? Okay, that point is the point. That point is the center is -2, -3. That point is the over part is -2, -1, because I move over 2 units, que es the radio. Downward is minus 2, minus 5. Because negative 3 minus 2 is negative 5. And that point, well, that point is a coincident with the y-axis. Entonces es the 0, something, 0, negative 3. And this guy is negative 4, negative 3. Boom. This is my circle. One more time. I encourage you doing this job using Desmos because it's easy. It's easy, it's fantastic. You can verify if everything is okay because when you have perfect coincidence in between the new equation and the original equation, it's because we are doing well. Okay. Let me see. Share. To Desmos, switching to Desmos. Is it Desmos now? Okay. Do you see Desmos, right? Do you see? Do you see? Yes or no?
Yes, I see it.
Yes, Professor.
Wow. Who make a noise? Because I need to investigate who make a noise. I'm putting off the microphone. Hello. Okay. I am doing Desmos. Okay, where is Desmos now? Here, over there. Do you see now? This is example 6. Okay, call example 6. Look at that. Boom. Look at that. This is the point. This is the equation. I have two equations. One equation in green color and one equation in orange color. And orange color is the given, the original. It's a general form. And they do the graph of the green, okay, the standard. After the transformation, bang, we have perfect coincidence. Fantastic. Do you see that? Do you see that?
Yes.
Everything clear? Those guys, highly recommendation. When you are doing the graph in the test, or in the homework, or in either way, don't do that in the piece of paper. No. Open Desmos. This is important because maybe, I don't know, you need to take another advanced class. Calculus, pre-calculus. It's more complicated graphic, and you can do that. However, in the test, it's online. So I don't know. You, for example, this picture, you go here, click in share graphic, and export. One, as a picture, and you attach in the test. Okay, you download in the specific format of the picture, and you attach or copy paste, no? And this is one fantastic way to do that. Well, some people say, no, I don't like. Okay. So you are drawing the piece of paper, it's okay. Either way. Okay, guys. So now, so you understand the circle part, I promise que in the review package we move it over again that part, pero no, we continue on new section in which I want to explain functions and relations. New, important, complicated. Functions and relations.
I don't see the whiteboard.
No? Okay. Now, Yasmin? Now, Yasmin? Do you see or no? No, yet.
I see the whiteboard now.
It's still on Desmos on my end.
Oh, wait, let me.
I see it.
Do you see? Well, okay. One possibility to make sure I go to here, stop sharing, not sharing anymore. You see my face now, no? You see my face now, no?
Yes.
Now, I share screen again, select whiteboard, start sharing. Boom. You see? Do you see? Answer me.
Yes.
I
Good.
do.
Okay.
Yes.
So let me start for the easy part, is relations. Relation is association between two sets. So we have relation. We have, for example, we have two sets. To illustrate this idea, I create a situation. The situation is, suppose you have one set I want to call capital X. It's a set, guys, set. Capital X is a set of my students in MAC1105. But another class, not your class, another class. It's another, I teach in some class. Entonces, you can listing the set, write the element, and separate by a comma. For example, Sally is one student, comma, Paul is another student, comma, King is another student, and Luis is another student. So I suppose to not complicate too much this problem. So we have 4 students only, no? Okay, so now we have another set. So to make a relation, we need 2 sets. The first set is the set of the student in MAC1105 class. And the second set, I want to call Y, que represent the overall grade that you can get in college. Entonces, the category que we have is A, oh, excellent, B, C, D. So you get D, you need to repeat again the class. And F is whole, you know? Entonces, remove the scholarship, some problem. To say, I suppose that everyone get A with me, no? I suppose. Okay, so now, you have to set. This is the first piece of information you need. And what about relation? Relation, by definition, is relation. By definition, is the connection, is the association. I associate one element of the first set. By the way, this set is called a domain. The terminology of the mathematical domain is the element of the first set. And the second is range. We're talking about frequency domain range. Because we have 2 sets. The first one is domain, and the second is range. And you create association. And how you represent the association? Well, you represent like that, like an ordered pair. For example, Sally, you open parenthesis, Sally, comma, because Sally get A. When the class is over, Sally get A because she's an excellent student. And Paul is good, but not too much, B. King get B also. And Luis is super excellent student, get A. Okay, and this is the symbolic way to represent relation. So like an order pair. Okay, entonces now in mathematics, normally, well, we can do it that way, but this is not the only way. We are doing, you define relation using also equations. We see every possibility here with me. Or graph. Because the graph, when you plot in the rectangular coordinate system, is x, y. It's another possibility, no? So not necessarily the set is people or it's grade. I put one example to illustrate this idea, but in mathematics, normally we use a number, no? Okay, to define a relation. This is relation. Now let's go to the hard part of this case, a function. What is function. What is function? Function is a little bit complicated to understand. Functions. Function is a little bit, because the definition, in my opinion, is very, very confusing. Okay, function is a relation, pero es special relation. Es relation such that each value in the domain, remember domain was the name, the generalized name to say is the first set. You have to set the first one because the order is important. No? Domain is associated with, entonces this is the most important word in the definition, with only one quotation mark, because this is an important phrase in the definition, value in the range. Okay. But this is, in my opinion, is very, very confusing. Let's see example to understand and clarify this idea. Look, suppose now that we have to set capital X and capital Y. Entonces, to simplify the thing, no people, number 1, 2, 3, 4. 1, 2, 3, 4. This is the first set, get the domain. And the second, get the range, is not necessary number, because maybe number is confusing. I put the letter A, B, C, letter A, B, C. Entonces, I want to declare now here with you two relations, and we investigate see these relations are a function or no. Okay, according to the confusing definition. Okay, relation 1. Relation 1 is, remember the relation is the order pair. You associate one element in the domain and one element with one element. So, suppose 1, A, 1A put together, 2, B put together, 3, C we put together, and 4, D I put together. Okay, and my question is, this relation 1, is a function or not? Satisfy perfectly the definition of the function or not? What do you think? Yes or no? Remember the definition say, no too clear, but say, okay, one element in the domain, okay, 1, 2, 3, 4, is associated with the only one element in the range, que es A, B, C, D. The answer is yes or no?
Yes.
They say yes. Okay, and she's right. Let's see relation 2. Be careful because this is confusing and complicated. Suppose this relation 2, okay, 1, A again, comma, 2, B, comma, 3, B, comma, 4, A. Okay, what do you think? This relation 2 is a function or no? This is 50-50. No? Yes. Who believe que es yes or who believe que es no? According to the, it's a yes, Angelica is a yes. I agree with her.
I go for no.
Some people believe que es no. Some people believe que es yes.
No, because because what's happening here is that A is being shared with 1 and 4, and B is being shared with 2 and 3, and it's and it's supposed to be only associated with only one value in the range.
There's some people say que no. Entonces, you incline the balance que es no. Well, you are totally wrong. It's yes. Let me explain now. Look, one schematic way to understand this is, okay, the confusing part is que 1 is associated with the 1. 1 is associated with the A. And 4 is associated with the A also, no? Here, in this. And 2 is associated with the B. And 3 is associated with the B also, no? According to the definition, each value in the domain is associated with the only one. So the important thing in the definition is that we have only one element in the range. Okay, what is the violation? The violation is that you, for example, you associate 2 con B and C. This is no function. Do you understand now? Do you understand now? The answer is just yes also.
Yes, thank you.
Okay, the important is only one, but in the range. Maybe we have repetition in the domain, maybe, no problem. This is no contradiction with the definition for the function. Let's see one more example. Relation 3. And relation 3 is suppose 1 comma A, comma 2 comma B, comma 2 comma C, comma 3 comma D. Okay? Entonces, in this case, wow, I see something weird here because professor, look, in this situation happened that part is totally illegal. 2 is associated with the 2 values. So this is the violation. 2 value in the range. Si it's only one, it's perfectly legal. Do you understand now? Do you understand now?
Yes.
Yes.
Okay, now, in order to summarize everything, yeah, Angelica, okay. In order to understand, let me summarize everything. I select 2 examples, okay, including one more detail. Suppose, forget about this. Another example. And when you have one relation 1, it's completely different. Forget about X and Y. Okay, is this 2,3, 4,1, 3, -2, and 2, -1. Okay. Is a function, yes or no? Entonces I include inside this question, include the declaration of the domain and range. Now we have 3 questions. Is a function? It is a function? Yes or no? Of course, argument, why no, why yes, or and define domain and range. What do you think, yes or no? What do you think, yes or no? Hey, are you, no, Angelica said no. And what is violation? What is the violation? What is the violation? What is the violation? The violation, no, 1 is a no.
2 shares,
Exactly. 2 with is associated with the 3 and -1. This is the violation. And domain, remember by definition, is the set of the first element in the first component. Remember, in the order pair, we have 2 components. No, this is the first, this is the second. The domain is 2, is 4, is 3. And not necessarily when you have repetition, 2, you copy 1 time. Because this is important property for the set. The set, no repetition, no necessary repetition. So suppose you have this set, 2, 4, 3, and this set is 2, 4, 3, and 2. Well, you can, but this is our equivalent. So no necessary repetition. And the order is not important. So the set 2, 4, 3 is equal the set, for example, 3, 4, 2. So the ordering is not important. This is 2 important property of the set. No important the order. It's the same. Doesn't matter the order. And no repetition. And the range is the set of value of the y, que es 3, es 1, es -2, and negative. Everything is clear? I have another example.
Yes.
Yes, perfect. I have another example. Very interesting. Suppose relation 2. And the relation 2, we have 2,3. We have 4,3. We have 3,3. Wow. And we have 5, -1. Okay, the same question. It is a function or no? Domain and range. Domain and range. Please help me. Any help?
Yes, it is a function.
Super. You are the best. And what about domain?
Because the domain are all different numbers. 2, 4, 3, and 5 are
Excellent.
the domain.
Excellent.
Whereas
and what about range?
the range is 3 and -1.
End the story. Super good. Any question, guy? This is airplane. Okay. See, everyone understand that part. It's very confusing, complicated, in my opinion. Let's move on to another inside the same topic, the function. This chapter 2 is basically function, and manipulation and study in detail the function. Okay, the next topic inside the function is identify if the graph is the function. Okay, you need to identify the graph of the function. The graph of a function. Suppose one graph is given in the test, and you need to identify if this graph corresponds with the function or not. So one fantastic way or fantastic tool to identify that is using one thing is called vertical line test. Vertical line test. And so now we have suppose different graph given in the test. Suppose one graph like that, look like parabola. Another graph look like another function, look like another function, and this is why not as a circle we studied before. Okay, this I suppose this is x-axis. And this is y-axis. To identify, see this graph, number 1, number 2, number 3, corresponding with the function or no, you apply the vertical line test. And what consists the vertical line test? Well, you are doing hypothetical vertical line. This vertical line look like a rain. The rain drop to the graph. If this vertical line crosses the original curve in only one point, yes, it is a function. Si cross in only one, yes, it is a function. Si cross in two, it doesn't matter in another point, don't cross. But see, at least cross in 2 or 3 or 4 points, more than one, no function. And here, exactly the same, no function. And this is logical. This is logical because the situation that happened here is, let me make it soon to see more clear, that x value is associated with the two different y. Y1 and y2. So the picture is 1x inside the domain. I suppose that the independent variable is domain is associated with the two different y. And this is totally violation of the function definition. Okay, vertical line, vertical line, vertical line, vertical line, vertical line, vertical line. Do you see that? Okay, nice. Any question? Vertical line test. No problem with the vertical line test. And in our exam, maybe we have a question. I give you the graph and you investigate if it's or no function. So the fantastic tool that we are using is the vertical line test. Okay. A problem in the chapter 4, we studied one similar test. It's called horizontal. It's another thing. Now we continue with the function, and you identify the function, but in this case, no graph, equation. The equation is given by the equation, and you investigate if our equation corresponds with the function or no corresponds with the function. Entonces, well, let me recall something first. Okay, and actually we have two kinds of equation in algebra. The equation que es implicit form. Okay, implicit is an explicit. Let me start for the explicit first. It's more clear. The explicit is clear, super clear. Is when you have the y value isolated. Example, to understand this. Y equal minus 3x plus 5. Okay, y is isolated, look at that. Y equal x squared minus 6. Y equal 4 over x. So when the y is isolated, it's explicit. And explicit is synonym to see clear, easy to understand. Entonces now when you give me, when somebody give me equation to say I need to investigate if it's a function or no, the first thing you should do is isolate the y because I want to see clear. Unfortunately, and the problem no explicit. Sometimes it's given an implicit. Implicit is confusing, no clear. Suppose the same as 3x plus y equal 5. In this case, x and y is mixed together, no isolate y. So this is implicit. Okay, this is exactly the same. They are equivalent one by one, but this is clear and this is not clear. You need to be aware for that situation. So one equation is given. I want to investigate if it's a function or no. Entonces es expressed en explicit. Let's see example to understand more clearly. Example 1, straightforward. Y equal x squared. I need to investigate this equation que es or is not function. Okay, I can see que es explicit.
Yeah, because y is isolated.
Because y is isolated, then I can see, like it works, when you define one value of the x, you get only one value of the y. Another way to visualize this is a parabola. This is a parabola, like that. And when you apply the vertical line test, crossing only one point. So 1x que you declare, suppose que you declare x equal, I don't know, 5. When you plug it in the function, the answer is 25. No two values, no 25, 30, 40, no, only one. Entonces es ese function. Okay. Different situation happen in example 2. Sí. Okay, Alex. So this is x equal y squared. I change a little bit. So my question is, this is explicit or implicit?
It's implicit.
It's implicit. Very well. Because y is not isolated. As it is implicit, it's not clear. It's confusing. Therefore, I need to solve for y. How do you solve for y? Easy. You apply square root both sides. Entonces you have plus or minus, double sign, remember square root x equal y. Wow. Now I change to explicit now. Explicit is more clear to understand and see is a function or not. I see que no, because one value of the x you pick, you select, you get two values of the y. One positive and one negative. Okay? So you want to make sure we are doing the graph of this, and this graph, the original graph, the original equation, okay, it's implicit. When you are doing the graph in decimal, maybe, you get the parabola like that. This is the parabola when the x is square, and this is the parabola when the y is square. And when you apply the vertical, the famous vertical line test,
I concluded that it's not a function.
Exactly, not a function. Very, very well. Do you understand very well the idea, guys? Do you understand very well? Okay, super, we are the best. Let's continue with the function, but another topic. So now, well, no sé, in the review packet, we go over again to this. I know it's too much information, it's a little bit, not complicated, it's not complicated, but it's too much, I understand that. Okay, now let's move on to the function notation. So one special notation that we are using in algebra, function notation. Function notation. Okay, what is that? What is function notation? Well, is one notation, special notation, que is super useful in algebra, in which you declare instead of y, you declare f of x. Okay, is f represent the name of the function. Okay, this, the most common is f, but not only f. We are using throughout the course another letter, G, H is the most common, no? P, M is a name, it's just a name, right? In the chapter 4, I promise we study a special function, okay, the name is LM, LOG, etc. So you open the parenthesis and you put here the element and the argument, you put the element of domain. And this parenthesis don't indicate us multiplication. No, it's totally symbolic way to indicate that. Entonces, the idea is, bueno, professor, okay, I understand, but what is the application? Let's see. Relax, calm down. Suppose this, okay, elementary example. Suppose f of x equal x plus 6. This is just example. Divided by 2x plus 3. Entonces, suppose que I want to, or I need to evaluate, suppose n2. Now you replace x for 2. Okay, and the function notation look like that, but in the algebra part is 2 plus 6 over 2 times 2 plus 3. That you replace x for 2. Automatically, any x you replace by 2. Que es the value that you plug in here. So this is 8. Okay, 2 plus 6 is 8 in the top. 2 times 2, according to the order of operation, you are doing the multiplication first, no? 2 times 2 is 4. 4 plus 3 is 8. Boom. And this is the final answer. Okay? And we are doing a lot of things using function rotation. We are doing translation, reflection, etc. Any transformation that I promise that we study in detail, not today. Today we have no time for this. But this, the important thing is the application for the function notation. Okay, look, translation. What is translation, Professor? Well, is when you put, for example, x plus 2. Translation. So you take the original and you do something, it's called a transformation. I promise I want to explain in detail in one moment, not now. The thing you need to focus is in the function notation. No? So is you replace x for x plus 2 and the original. Look at that, look at that, look at that. This is my original example. And now you replace x for x plus 2. X plus 2 plus 6 divided by 2 times x plus 2 plus 3. And leave it like that. No. This is correct, but it's incomplete. Just x plus 8, because we combine like that. This 2 plus 6 is 8. And here you apply distributive property. Why not? 2x plus 4 plus 3. And the final answer is x plus 8 by 2x plus 7. Okay, and it's no surprise. Okay, this looks like similar to this. Because you consider that x is 0 here, it's just this. So see, you delete that part mentally. It's a over 7. But don't worry for this. This is not important. The important is that we can using the function notation make translation. You say translation in what direction, Professor? This is the topic we discuss after. Now reflection. Reflection is when you make a reflection, and reflection is super useful. You change x for negative x, and you make a reflection like a mirror, No, to say you are doing reflection. To say what is the reflection? Well, you replace x for negative x in the original. So say it's negative x plus 6 divided by 2 times negative x plus 3. Leave it like that. No. It's much better for me is x 6 minus x. We put a positive first, and 3 minus 2x. Okay, and this is the result when you make a reflection this original function, no? Okay, reflection, and also the function notation is useful, and we see in the chapter 3. Okay, basically the chapter 3 is too many graph. And they find, for example, Y-Intercept. Suppose you have function. I need to find two very important points. Is the Y-Intercept. Y-Intercept is the point in which, for example, the curve crosses the y-axis. You say, what is the formula? Professor, I don't remember the formula to find the y-intercept. Well, it's easy using function notation because you evaluate the function in 0. And you declare x is 0 and you find the y-intercept. Likewise, similarly, to find the x-intercept, is the point that the curve, that curve, crosses the x-axis is the function notation is f of x equals 0. And this is a mnemonic device can help me because it's visual, no, to understand the intercept. Let's see example. example of the application of this. Okay, look. Suppose this example is f of x equal absolute value x plus a. And the professor say, do the graph of this. So in order to do the graph of this, let's try to find the y-intercept and x-intercept, que is very useful point in the graph. Entonces yo valor en 0. Wow, easy. Absolute value 0 plus a es absolute value a, que es a. Wow, entonces the point is the point 0,a. Okay, our graph crosses the y-axis. It is the y-intercept. Using function notation, it's easy to remember that you evaluate 0. Now, likewise, you want to find the x-intercept. Well, okay. Entonces, the memory device say f of x equal to 0. Who is f of x? It's x plus 8. Actual value equals 0. Wow, easy. This is a equation that contains actual value, similar to the test 1. And you solving that. How you solve it? Well, you have one solution, right? Because on the right-hand side is 0. We have one solution. So you remove the bar equal to 0. Therefore, so for x equal negative. And the point is the point negative 8, 0. Because the supposition behind this idea is that y is 0. Look, y is 0. And the supposition behind this idea is that x is 0. Okay, suppose que I'm doing the graph. I have no idea, but at least I have in my hand 2 points. The first point is this, 0,8, and the second is this, negative 8, 0. I anticipate you that the graph look like that. That part I have no idea, but you put in this mode maybe. Okay. Okay, this is the application of the function notation. So now, how I evaluate this in the test? Well, always is the same in college algebra. Always is the same. Look, this is a classical example in college algebra. Any course in any campus, you, in order to apply in the test 2 the function notation, we use one thing, it's called different quotient, difference quotients. This is a classical topic calculus. But from algebra, you see something, no? So this is a formula. Different quotient is the formula. Is fx plus h minus f of x over h. This is a formula. The formula is called different quotient. Now, I promise you see the student can need to take calculus. Okay, and if you want, we discuss in the interpretation of this, but no important now. And one function is given. Suppose the function gets given in the test as x squared minus 5x plus 6. And you need to compute that. So this is our goal. Quotient, different quotient. This is the formula. So I try to do step by step. Step 1. Step 1 is compute the first part of the formula. Is this. Okay, the first part is that one. Boom, boom. Okay, entonces easy. You are doing some translation. Entonces es replace x in the original equation is given to x plus h. Entonces x plus h square minus 5 parenthesis x plus h plus 6. Do you follow me? And leave it like that, no? Oh no. You apply distributive property. You apply FOIL maybe. X plus h times cell. You FOIL x squared plus x times h plus, again, repetition, x times h plus h squared. I did the first part. The second part is distribute the properties. Easier. S minus x, x minus 5h plus 6. Okay, and this expression is fx plus h. I am doing one translation. Everyone follow me? Look like hard or no? Step 2 is doing this and this together. Okay, basically, and the expression that we computed before, you subtracting the original is given. Entonces now I copy x squared plus xh. Well, actually, sorry, these and these are lighter, and we can combine only one, no? No, there are no reason to copy separately. No, because they are lighter. Entonces, 2xh plus h squared minus 5x minus 5h plus 6. Subtraction, look at that, the original. And when you're subtracting the original, get this. When you put a minus in the front, every sign change. X squared plus 5x minus 6, something like that. This important moment, this is a crucial moment. A lot of people is canceled. It's canceled this. This cancel also this and this. And stay alive only 2xh plus h squared minus 5h, and that's it, no? 1, 2, 3, yeah. Okay, this is f of x plus h minus f of x. Finally, in the formula, divided by h. Look at that. Divided by h to satisfy this formula. And divided by h is super easy because it's a monomial expression, and so you divide one by one separately, like that. What's my final answer then? Okay. That part is cancelled. This is just 2x. That part is cancelled, but not totally. One of these and one of these. This is h plus h. And the last part is cancelled also 1h. This h and this h cancel. It's negative 5. Boom. Final answer. Different quotient formula. What is the interpretation of this? What is the interpretation of this? What is the interpretation of this? The interpretation is, you know, suppose you have function. Interpretation. This is extra. Not necessary to know. In calculus, you see clear. Suppose you have function. This is a function y equal f of x. This is x, this is y. You pick completely arbitrary point. Yeah, I want to call x. Now you translation a little bit to another. Next is x plus h. So that distance is h. And you evaluate the function. This is the value f of x. And this value is f of x plus h. And you, why not, make zoom to see more clear this graph. You, for example, are doing the line connecting this point and this point, like a secant line, like that. And this secant line, you know, approximate a little bit, not too much, to the curve. Entonces now, I suppose you remember the formula for the slope. Okay, we studied intermediate algebra. y2 minus y1 divided by x2 minus x1. It's exactly the same. We have 2 points. This point is the point x1, comma y1. That point is x2, y2. And when you compute the slope, using the formula for the slope, is y2 is, in our specific case, fx plus h. Minus y1 is f of x. Look at that, look at that. It's a y value. This value and this value. Actually, when you're subtracting, you get that distance. Look. That distance, get rise. And in the bottom is that distance, gets wrong. And wrong is h. This is the formula. So what is the meaning? The meaning is a slope. It's a slope. If you want to interpret it a little bit more logical, is like a rate of change of the function. Rate of change of the function in the specific point. You want to understand how fast or how slow the function change. So you apply the different quotient and help me to understand the rate of change of the function. Que es the geometric interpretation, is the slope of the secant line que connecting two points. Secant because it's not tangent. It's secant because when you have to point, suppose you have a curve like that, and you pick two arbitrary points. This line is called secant. Secant line. It's the slope of this secant line is the different quotient. This is one geometric interpretation. Another logical interpretation is rate of change of the function. Suppose that I am business, I want to understand how fast increasing my profit, okay, in the function. So I compute the different quotient and I determine that. Okay, but the important thing now is not the interpretation. This is your curiosity, no? Is the formula, the procedure to compute the different quotient. It's one application of the function notation that we studied before. I suppose you want another example, yes? Yeah, in the test, in the review package, I am doing another example. Let's do one super elementary, easy example of the compute different quotient. Compute different quotient of this given function is f of x equal to x plus 3. Oh, it's a linear function, no quadratic. Okay. And the formula for the different quotient is f of x plus h minus f of x divided by h. This is the formula. Okay, entonces step one is compute f and x plus h. I take the original, put 2, replace x for h, is the translation. Leave it like that, no. I remove the parentheses, apply distributive property, 2x plus 2h plus 3. The second step is compute the differences. Get the distance between the translation and the original. Okay, it's doing 2x plus 2h plus 3 minus this guy gets 2x minus 3. Wow, always happen in this step a lot of people cancel out. And stay alive only, look at that, 2h. Finally, step 3 is divided by h. Divided by h. Wow, so when you divide by h is cancelled and stay 2. Okay, it's no surprise because 2 is a slope. In this case, the function is a line. Therefore, you pick 2 points and you compute the slope. It's obvious the slope is mx plus b. Makes sense or is confusing? Makes sense or is confusing? Makes sense or is confusing? Come on. Stop here. I want to feedback. You
sense.
follow me or okay. for the topic so far is, for example, in the test, I will give you, okay, one graph of the function, and you need to identify domain range, identify domain and range looking the graph, by the graph. So one graph is given. For example, let me use my rule. Okay. Suppose one graph is given. Let me try to. Normally, the function is given in the test have different problems, like holes, like gaps. This is the x-axis. Okay, and y-axis 90 degree. 90 degree. Uh-huh. 90 degree, good. Let me try to do here. Okay. One hypothetic graphic of the function is given. And you investigate domain and range. Okay, suppose 1, 2, 3, 4, 5. Okay, here is 1, 2, 3. Okay, suppose one graphic is like that. Okay, so through here, but and 2 stop. And 2 we have a hole, and the hole is indicated like that. It's a circle open. And this arrow indicate also that this continues forever in that direction. But you know, I have no too long paper to say indicate like that. Entonces we have now a gap. And between 2 and 3 we have nothing. But I jump, I have a discontinuous to 3. And this symbolic way is a circle full or circle close to indicate that the function is defined. Okay, now I continue here down in that direction. This is my function this year. This is the function f of x. My goal is investigate domain and range and express it in interval notation. Okay. Look in the graph, I know. Look at the graph, I know. I know que f evaluating to is undefined. Why? Because this circle is open. Because we have no value associated with the 2. No. You believe que 2. No, but no, it's open. It's undefined. And in between 2 and 3, we have a gap. In the gap also, f evaluated 2.1, f evaluated 2.2, and so on, bam, 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 is undefined. The same thing. In 3, no. In 3, no. In 3, I saw that the graph have the circle full or close. That means yes, by coincidence, it's the same value, 3, 3. This is the x value, is this. And this is the y value, is this. Okay? So now looking the graph, the answer is what is the domain and what is the range. Okay, let's do it. Okay, to see you, I propose you. Wow. You moving on the curve. Different point. Bam, 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 bam. We have nothing here. Bam, 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 bam. In order to find domain, you projecting you projecting the curve onto the x-axis. Remember, domain by definition is the set of x value such that the function is defined. Si es undefined, not good. It's completely out. So I can see that our domain, at least in that part, is this. Stop and do. This part continue forever to negative infinity. But this and 2 not include 2 because I saw in 2 we have a hole. And between 2 and 3, we have a gap, nothing. And we have the continuation of the domain, is that part, and this continue forever to positive infinity. And of course, include 3. This is the important detail, guys. Bracket here, because this circle is closed. This circle no, is open. The answer is, the domain is from negative infinity, comma, 2 parentheses, union, bracket now, union bracket, 3 comma infinity. Everyone follow me? Okay, repetition. Domain is the set of the x value in which the function is undefined. At the beginning, we suppose all real number. Pero no. In this case, we have problem because in 2 is undefined, and between 2 and 3, there are a lot of bunch of values in which the function is undefined. So I need to exclude this guy outside the domain. And what about range? Range is similar, but when you're talking about range is the set of the y value in which the function again is defined. Okay, because the only difference between domain and range is that range is y value. So the projection that we are doing in the point, black point on the curve is onto the y-axis. So now, suppose you're projecting this. Look, you're projecting this. And what about 2? Well, 2 no. 2 no, because in 2 we have something here. What we have a hole, no? But okay. Entonces, the value 2 is defined or is undefined? No, wait. It's not too easy because it's undefined in 2. But here, you projecting, for example, this point, I don't know, say 4 point something, is also 2. Therefore, 2 is okay. 2 is okay. Not in 2, but in 4 point something, yes. And continue here, continue until here. Stop here. Okay? Now, using the blue color, this is from negative infinity. And here we have 3 case bracket because include, you know, and 2 is also bracket, no? But no necessary bracket because it's inside. So we're using bracket or parenthesis in the endpoint, not in the intermediate point. Okay, so the range in this example is from negative infinity, comma 3 bracket. End story. Super. Okay. Any question? Okay, this is one typical question. I promise that we go over again. But this is a typical question in the test. One graph is given. So you need to be aware. Some problem is holes and gap. And the symbolic way to indicate this, a hole is indicated using that symbol, no? You have a curve, we have a hole. And the hole is undefined. You erase that part. Boom. We're using this notation after, not today. Okay. Let's discuss it now. And the rest of the time we have. Let's discuss it now. The determined domain This is the most complicated part. Determine domain using the equation. Okay, and the test, one equation is given, and you need to determine the domain. So what is the assumption? What is the supposition? The supposition is domain, you know, range is more complicated. Forget about range and that part of this equation. Domain is, by definition, is the set of x value in which that function is defined. Si it's undefined, it's completely out of the domain. So what is the assumption? What is the supposition? The supposition is that the domain at the beginning, you suppose que es all real number. Except restrictions. And what about restriction? What's the restriction? Well, restriction, there are several restrictions. The restriction, the most elementary restriction in algebra is number one restriction. Suppose you have two functions, division. Well, the restriction is the function in the denominator, no zero. Because I know that division by zero is illegal. Okay, entonces suppose que is given, let's see in the example right now. Something divided by something. I don't care P. P is not important in this analysis. You take the expression in the denominator and you enforce it que never is zero. Okay, and this is the restriction. Division, restriction. Square root, restriction. Okay, because the expression E inside the square root must be non-negative. Because you know what happens when it's negative. If negative is imaginary, imaginary is completely out the all real number. This is all real number. And the combination 1 and 2 together is suppose P divided by radical E. Well, in this case, E must be positive only. Zero no, because of division. Okay, this is the most important restrictions. I promise in the chapter 4, we study another restriction to complement the idea of the algebra. But this is the restriction, and they are combination. Because in one equation, maybe you have 2 or 3 restrictions. And they are combination to say you want to investigate the domain, you set out the inequality, you satisfy the domain, and you find this. That is the reason in the chapter 1 we study inequality, no? Okay, let's see example 1 to understand. This is very confusing. We need to practice a lot of to get this idea. Example 1 is a function f of x. It's the name of this function. It is x plus 4 divided by x squared minus 2x minus 3. Wow, it's given this function. And the function is given, the equation is given. The equation is given, no graph, no equation. You say now, well, the supposition is the domain is all real number except the restriction. And what is the restriction? Well, I take the restriction 1, look, this restriction. And the restriction 1 is you take the expression of the denominator. I don't care in this analysis, the expression in the numerator, this is not important, irrelevant. And you focus in the solution of this inequality. Well, entonces, for me, it's very, very confusing solving this inequality. I never see that in my life. But I am super familiar with the quadratic equation. So I transform it to quadratic equation. I transform this symbol to this symbol. But I know that this is a complementary idea. So this is the bad guy. I need to find the bad guy. But when you convert a non-equal sign to equal, so this is the good guy. But it doesn't matter. Okay, you solving that. I suppose the easy way to do this is by factorization. And the combination is obvious 3 and 1, no? Because 3 times 1 is 3, and 3 minus 1 is 2. The signs are negative and positive. Okay, factorization. Or quadratic form, either way. I suppose it's easy factorization. Therefore, you break it down into linear equation. The first solution is positive 3. And the second solution is negative 1. Because actually, this guy que I solved like a quadratic equation is not equal. And that becomes like a bad guy in this case. So my domain is all real number except 3 and negative 1 is the bad guy. Let me try to interpret this because I want to express it. The final answer in interval rotation always in the test. Always, anytime. Okay. Okay. 90 degree, no, 0 degree. This is my all real number line. From negative infinity to positive infinity. This represents all real number, guys. 0, you know, in the middle. And this is 3. 1, 2, 3. And it's a negative 1 here. Negative 1. Entonces, what happened in positive 3 and negative 1, we have 2 holes. 2 holes. 1 hole here because it's illegal, and 1 hole here. It's illegal. So what is my domain? Well, my domain is this part, and this part. Any number inside the bad guy highlight now in blue color is okay. The only bad guy in this game is negative 1 and positive. This is parenthesis, 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 and parenthesis. What is my final answer? Domain. Domain is from negative infinity, comma, negative 1, parenthesis, union, negative 1, comma 3, parenthesis, union, 3, comma infinity. End the story. This is my domain. This is the way I want you present in this. One more example, and that's it. Well, I don't know. I have a lot of examples of this part. This part is extremely important, guys. Everyone follow me? Everyone follow me? Are you boring? Too much? Come on, feedback. Feedback, I want to see. Opinion. You follow me? Confusing? No? Okay. Okay. This is a good class. I know. I feel, after the first test, I feel. Remember, we have a student of the continuation with me intermediate algebra. And I suppose this student, no, I am sure. These students are strong, solid, and the manipulation, the equation, something, right? And the other students, the new students are good. I feel good. Okay, remember Friday is the last day, the last opportunity to turn into me the pending test that you have. No, I emailed for some students with this situation. Example 2 now. Example 2 is the function is called g, is the name of the function, square root 3 minus 2x. And the question say, bueno, express the domain. Right, and in interval notation. Well. So I recall the restriction. Remember restriction 1, division. The expression in the bottom, non-zero. It's a restriction 1. Restriction 2, square root e. The expression inside the square root, non-negative. Restriction 3, combination both. Expression inside the radical, positive. In this case, in this example, the restriction matching perfectly is this one. Because we are talking about square root, no? But square root in the top, not in the bottom. This is in the bottom. Okay, so now immediately I transform this problem in this problem. You copy the expression inside the radical without radical, no radical, the radical is gone. And I enforce it to be greater than or equal to 0. Boom. And you focus it 100% for solving this inequality. But it's easy. Negative 2x greater than or equal minus 3. I move 3 to the right hand side. Now divided by negative 2. It's x alone, negative 2 divided by negative 2, positive 1. But when you divide, don't forget this detail. When you divide inequality by negative number, you have to reverse this. And this is 3 over 2. And by the way, 3 over 2 is equal 1.5 decimal. No? And it's useful to represent in decimal to see more clear in the number line. Boom. Personally, I like do the graph because it's useful to understand much better the interval notation. This is 0, this is 1, this is 2, this is 3. A 1.5 lie exactly in the middle and between 1 and 2, 1.5. In what direction? To the left. To the left. So it's in that direction. Stop here. Include the endpoint. Include 1.5. Of course, including the 1.5. Because I saw here equal. Therefore, 1.5 is inside. That's what is my domain. My domain is equal from negative infinity, comma, 3/2, either way, or fraction, listen, doesn't matter. 3 over 2. But this important thing is the bracket. Any question? Super good. Entonces I promise que Friday we continue doing more complicated problem of the domain. This is extremely important. And we start doing the next inside the function, more complicated combination, composition, piecewise function, que es no super big deal, pero es a little bit weird. Okay, guys, so now we finish today. Don't forget to submit. Friday is the last day.